Okay, we're back for another reading from the Rust programming language book, and today we're covering an example program using structs. So let's just dive right in. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. Length times width, that should be pretty straightforward. We'll start by using single variables and then refactor the program until we're using structs instead. I think that's probably a pretty good way to learn a programming structure, literally structures, but also as a broader point. Try doing something in a way that doesn't use that programming feature, and then see if you can translate it into that programming language feature that you're trying to learn. So let's do just that. We'll go let width be bound to the variable value 30. It's complaining up front that it's a unused variable, but we'll use it in just a moment here. So let's see. We've got width. It's an integer 32 type, signed integer, and we'll say we also have this variable height 1, which will bind to the variable to the value 50. And then we'll go print line macro and just type out our message here. The area of the rectangle is blah, 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 square pixels. Blah, blah, blah is a technical term in this area. And we'll then call our area function that we haven't defined yet, but it's okay. Like, Rust doesn't get mad if the function is defined outside of the main function after the main function. That's okay. And we'll go height 1, no semicolon there, but let's put a semicolon here at the end of the print statement. Okay, so for one thing, it is expecting a comma there. That's an easy problem to solve. And now we just have this problem of defining the area function. Doesn't exist in the built-in prelude of Rust, but we can certainly add this. So function area, it'll take an argument called width. Let's call it a U32 type, and height U32. Probably worth mentioning actually at this point, since just turn that off for a moment, that at this juncture it's assuming that it's going to be I32 for these input types, but here we are defining a downstream, not downstream in terms of data flow, but downstream in terms of definitions, area function that's going to say that they're U32s. And so we'll take a look in just a second at what happens when we do that. So we have width times height. That's pretty straightforward. Now if I pop back up to here, notice that my LSP, Rust Analyzer, is telling me that it's now U32, not I32. So Rust is pretty smart. Not just this LSP Rust Analyzer tool, not the static analysis alone, but actually Rust also at the compile time knows to infer these types for us, which is quite handy. Okay, that's not really the point of this example though. Just thought I'd mention it since we happen to be changing over types as we went along. So we go cargo run, that just compiles the binary and then runs the binary at its path. And of course we could run it from the target here, whichever way you want to do that. So one thing you may have noticed that I just noticed is I didn't spell area correctly, but that's okay. That's a pretty small little thing. And then we rerun, we recompile, and then we get this this area of the rectangle is 1500 square pixels. Okay, great. So that's some program. We're still not on structs yet. This is just showing an example program that we can talk about. So now let's jump back into the documentation here. This code succeeds in figuring out the area of the rectangle by calling the area function with each dimension, but we can do more to make this code clear and readable. So this really gets into opinion territory right away, where for such a simple example, I actually would prefer not to use a struct here. Like if this was genuinely all that the program was, I don't think that structs are actually a good thing to add. However, if you're dealing with lots of rectangles, you might want to use a struct. Even then, it's kind of a maybe depending on how you want to structure things into like vectors or whatever else. But at least there's some interesting point there to say I've got a collection of these rectangles and I want to compute their areas. Anyway, we're getting ahead of ourselves. So the issue with this code is evident in the signature of area. Which issue? Area, the width, U32, whatever. The area function is supposed to calculate the area of one rectangle. Yes, true, but the function we wrote has two parameters, and it's not clear anywhere in the program that the parameters are related. I see. Though that's true, actually, yeah. I mean, that's an interesting point, that there's nothing explicit in the code beyond that we called the function with those parameters together that actually suggests that those are special numbers that relate to the same rectangle. All right, I can buy that. It would be more readable and more manageable to group width and height together in some way, which we're going to find out as a struct as one way of doing it. We've already discussed one way that you might do that, the tuple type section in chapter 3 by using tuples. Sure, of course, you could use a tuple for this, or even like a vector of tuples if you wanted to have like a collection of these pairs that each correspond to a rectangle. It really just depends on what kind of trade-off of like the richness of the representation you want, the kind of computational efficiency you'll get from that, versus the richness of the description of the state of things. No magic answer there. Refactoring with tuples. So we're moving on to another subsection here. Listing 5-9 shows another version of our program that uses tuples. Okay, well, let's take a little look. We could break that down. So let's let rectangle 1 be bound to the value of 30, 50 being a tuple, and we need to close that statement, and we're going to get some other errors here. Let's pass in our rectangle tuple, and then we also need to correct this type. Notice how this would be like a breaking API change, right? Nonetheless, okay, you could say, oh, they called it dimension. Maybe I should follow suit here. Dimensions, call it the tuple of a pair of U32s. We will call it the same. And what are we going to do here? We're going to go dimensions dot 0 multiplied by dimensions dot 1. So that's different than like arrays, because arrays you would use, I think it's square brackets with 0 indexing. Here it's a dot notation, which is kind of interesting. I guess it helps you at a glance know that they're different even before checking the code or doing some kind of analysis of the types. So let's just make sure that that actually compiles. It compiles. Great. I like it when it compiles. So in one way, this program is better. In a way, although I still actually think that if, you know, the context is king here, and if you really genuinely just wanted to multiply a couple of numbers together, I don't think you even need this function. You could have just taken these numbers and like multiplied them together right into the print statement and whatever. And that's assuming you wanted to even use Rust. At that point, I don't see why you couldn't or shouldn't just use some, you know, scripting tool, whatever, I don't know, even Excel, if you're just multiplying two integers, although I'm not a big fan of Excel, not to get into that right now, but suffice it to say, like, you could do this in Python easily, right? I mean, you could take something like Python print, and what is it, 30 times 50, voila. I mean, we could add more of what like is the formatted print string or whatever, but easy enough. So the point of these kind of examples is really to teach you some of the programming mechanisms, but they do lack the very thing that is king in developing software, which is the context around it. There's no, like, in general, right answer. You have to look at the context, and even then, there's not likely to be a right answer, but some things will pop out as trade-offs when you know more about the problem that you're actually working on. Okay, so tuples let us add a bit of structure, and we're now passing just one argument. Sure. I'm not sure that our goal should ultimately be to just pass one argument, but all right, it's something. So, but in another way, this version is less clear. Tuples don't name their elements, so we have to index into parts of the tuple, making our calculations less obvious. Well, that's true. Compared to the very first example, we actually named these. Structs get a bit of both. You get an encapsulation aspect to it. You get a naming aspect to it. These are nice things. So we have to index into the parts of the tuple, making our calculations less obvious. Maybe a little bit less obvious, but we're still in very trivial code land here. So mixing up the width and height wouldn't matter for the area calculation. That's true in terms of like permutations. It's a scalar multiplication. A times B is equal to B times A. It's commutative, right? But if we want to draw the rectangle on the screen, it would matter. For an area, no, it wouldn't matter. It's still invariant. However, if we wanted to talk about like width and height and then plugging that into some functionality that plots things to the screen, then yes, that doesn't commute. That's true. We would have to keep in mind that width is the tuple index 0 and height is the tuple index 1, which if we're only plotting one rectangle, that may not actually be that hard, but sure. This would be even harder for someone else to figure out and keep in mind if they were to use our code. Yeah, and again, when things get complicated, sure. Because we haven't conveyed the meaning of our data in our code, it's now easier to introduce errors. Again, context matters, but you can see how maybe in a really complicated code base that would be the case. So let's follow along with their next example. They're going to refactor into structs. Let's do it. So we're going to write struct keyword that helps us define that there's going to be a struct. And it seems like the most natural thing that we want to describe here is a kind of rectangle. So we'll say that what's in a rectangle? A rectangle has a U32 width and it has a height. It's also U32. And we'll put okay, auto format has my back here. Okay, so then we've got our main function, and maybe I'll also skip the main function just for a moment and write the area function. So here we'll have a rectangle type for our rectangle parameter. And actually, we're not going to pass the rectangle. We're going to pass a reference to the rectangle. Okay. And so then we'll go rectangle dot width multiplied by rectangle dot height. And even here, I'm sure we're going to get to it, but you can, yes, we are actually, there it is right there, methods. You can actually make functions like this part of the struct too. I'm not going to tell you that that's always the right answer, but sometimes that's a thing you can do. So let's define our main function here. We're going to define a rectangle, initializing it, and we're going to grab some choice of width. We're going to pick the same numbers just for consistency with the original example. Not that it really matters. And we'll say rectangle 1 is bound to rectangle initialized with a width of 30 and a height of 50. Great. And then we'll write out a similar kind of macro statement. The area of the rectangle is blah, blah, blah. It was 1,500 square pixels. Great. But we're not quite done because we need to pass something in. To be formatted, we're going to pass in our reference to rectangle 1. Remember, we're passing by reference, not by value here. Now, I see an error. It's getting upset that I didn't include a comma, and there we go. Yay for static analysis. Now we'll just go cargo run, compiles, gives us the usual output that we've been seeing across these different compile times. Now, here we've defined a struct and named it rectangle inside the curly brackets. We defined the width and the height, both of which have a type of U32 or unsigned 32-bit integer. Then in main, we create a particular instance of rectangle that has a width of 30 and a height of 50. This is just rehashing through what we just did with the code, reading it out for ourselves. Now, our area function is now defined with one parameter, which we've named rectangle, whose type is an immutable borrow of struct rectangle instance. That's true. As defined in chapter 4, we want to borrow the struct rather than take ownership of it. That is, we're going to give it back. This is temporary. This way, the main function retains its ownership and can continue using the rectangle 1, which is the reason we use the ampersand in the function signature and where we call the function. Totally. The area function accesses the width and height fields of the rectangle instance. Note that accessing fields of a borrowed struct instance does not move the field values. That's right, which is why you often see borrows of structs. Yeah, I think that's kind of convenient because you're usually going to want to get back control of that rectangle or the main function or whatever the function scope is, it's going to want that. Sure. Our function signature for area now says exactly what we mean. Calculate the area of a rectangle using width and height fields. This conveys that the width and the height are related to each other, and it gives descriptive names to the values rather than the tuple index values of 0 and 1. This is a win for clarity. Yeah, by and large, I think so. Adding functionality with derived traits. Okay, so with derived traits, it'd be useful to be able to print an instance of rectangle, which for some people who are new to Rust might immediately be like, wait, what? I can't just like print the rectangle? So let's get rid of the area function. We don't care about that at the moment. And let's just get the same rectangle in their example. So we'll say that rect1 is, and we'll pass in rect1 here and put a little semicolon on that. And we have a problem. And in fact, the static analysis tools are already giving us a hint of that problem, that rectangle doesn't implement the standard format display. In format strings, you may use the colon question or even the colon hash or whatever you want to call it for pretty print instead. So I have a feeling like they're going to, in the documentation here, tell us about how to fix this, but let's just try what the compiler told us that we could try to do. Cargo run, derive debug. Yes. So let's put, this is also technically a macro of sorts. Derive debug. Well, that was easy thanks to some autocomplete. And let's give it a go. Cargo run. So I get some warnings that certain things were never actually read or used, but it's not inherently a problem. Now there is a kind of pretty print that we could also try here. Let's go cargo run. There we go. Okay, so it's a similar kind of thing, but it's now wrapped onto multiple lines, almost looking like the same as the code, actually. Nice. All right, let's read to see what they are going to tell us about. So when we compile this code, we get an error with this core message, error E0277. Memorizing that is not necessary. There's lots of ways to look up what that error is. Rectangle doesn't implement the standard format display, and it's a trait, I believe. So the print line macro can do many kinds of formatting, and by default, the curly brackets tell that print line macro to use formatting known as display. Output intended for direct end user consumption. Nice. So the primitive types we've seen so far implement display by default, because there's only one way you would want to show a 1 or any other primitive type of a user. But with structs, and I think this is important, they're explaining the rationale here of why this is the way it is in Rust, is because with structs, the way that you print it will depend on what you're trying to actually show about it. So should format the output, the way that it should format the output is less clear because there are way more possibilities for how to display it. Do you want commas or not? Do you want the print to print the curly brackets? Should all the fields be shown? I think that's probably one of the ones that I would start thinking about, is to go, you know, if I wanted to print a whole bunch of structs, does it really need to print like actually everything about every single one of them? Or would I want, in some cases, a way of just showing certain subgroupings of properties, or actually I'd probably do structs within structs or something like that. But you know, even if it's a struct that's just got a lot of attributes at that top flat level, I might not want to show all of them, especially if there's a large number of them. Now, due to this ambiguity, Rust doesn't try to guess what we want, and structs don't have a provided implementation of display to use with printline macro and the curly bracket placeholder. So the formatting placeholder. So what would I say about this? I think in a way I slightly disagree with the design, where I think this is something that probably would be good to have a default, even if it's a default that is still moderately often overridden with some custom display. Maybe I don't understand why there's technical reasons why we shouldn't do that, but on the face value of it, it seems natural enough to either have a rule that says print everything, in which case a lot of us will go, that's too much printing and we'll change it, or for something where it's just going to show like the top, I don't know, 5 attributes and then like a dot, dot, dot in the printout that shows there's more. Something like that. I think those could be reasonable defaults. I don't think it has to be this way. But I do agree with the idea that you should be able to override it. I'm just not sure that no default at all was better than having a default. But I don't know how Rust is actually implemented under the hood, so maybe I'm wrong about that. So if we continue reading the errors, we'll find this helpful note. Rectangle cannot be formatted with the default formatter required by this formatting parameter. Sure. Let's try it. The printline macro call will now look like a printline macro. Rect is rectangle, question. Yeah, I guess I did change even how I was writing this, but shouldn't matter. Here we are. Joy. Absolute joy. So, where were we? Inside the specifier, we've got this question mark inside the curly brackets that tells printline macro we want to use an output format called debug. The debug trait enables us to print our struct in a way that is useful for developers so that we can see its value while we're debugging our code. Compile the code with this change, drat, we still get an error. Yes. So that is one thing that I was quickly running into where I thought, maybe I just do like that. Cargo run, but alas, no. You do need to actually include this. So the derived debug is kind of an in-between where you can quickly tack on some kind of way of printing, but this debug option is going to be, I think, quite verbose, especially for really large structs. That's my assumption. Now, Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. Now I'm thinking again, okay, so why is this the default? So one possible reason is that in some environments, admittedly not ones that I currently work in, I think there could be some points being like, by default, I don't want to accidentally ever print some information that shouldn't be printed. So it could be like a cybersecurity and data privacy issue. Yeah. I mean, a lot of the code that I work with is not so vulnerable, but I could see that being the case for some code. Sure. All right, I buy that. All right. Maybe it's not unreasonable. Not that I really ever suspected that somebody didn't have a reason, really, but I didn't know one. So there's a reason that you could look at. To do that, we add the outer attribute derived debug just before the struct definition as shown in listing 5-12. Great. So we added that already because we followed the instructions from the static analysis tool, but that's great. Adding the attribute to the derived debug trait and printing the rectangle instance using debug formatting. Great. Now, when we run the program, we won't get any errors and we'll see the following output. Yeah, more or less. I think we did the fancier print, but it's a similar idea. Yeah, okay, that's exactly what they talk about here. Nice. It's not the prettiest output, but it shows the values of all the fields for this instance, which would definitely help during debugging. It could. Context. When we have larger structs, it's useful to have outputs that's a bit easier to read. In those cases, we can use this :# instead of :question inside of those formatting blocks in the printline macro string. So in this example, using the :# styling, we get this output, which is what we have over here. No problem. Another way to print out a value using the debug format is to use the dbg macro, which takes ownership of an expression, as opposed to printline macro, which only takes a reference. That's pretty substantial, actually. Like the dbg macro could kill a process, could result in a panic that a printline macro wouldn't. That's interesting. Prints the file and the line number where the dbg bang macro call occurs in your code along with the resultant value of that expression and returns ownership of the value. Oh, it returns ownership. Interesting. So let's just give that a try. I am curious. Let's go dbg rectangle 1. Is that it? Or go run? Yeah. Oh, there it is. So that's kind of neat. And like they said, I mean, it tells you the where in the code it actually occurs. Nice. What is next? So note, calling the dbg bang macro prints the standard error console stream as opposed to the print line macro, which prints to the standard output console stream, standard out. So I think that that's probably appropriate. Like if you really wanted to push something to standard out so that you can use it in a standard stream pipeline, then you probably shouldn't be using the debug tool. I don't have an opinion really on why, like, if print line macro should be the way to do that, and maybe there are other ways to put strings of bytes, sequences of bytes into standard output, some other ways, but definitely the debug option doesn't seem like the way that you should do it. Here's an example where we're interested in the value that gets assigned to the width field, as well as the whole struct in rectangle 1. So what do we got here? Okay, they're just doing what we just did, although I think we passed reference, or passed value. They're passing reference. Interesting. Okay, so we can put dbg around the expression 30 times scale. And because dbg bang returns ownership of the expression's value, the width field will get the same value as if we didn't have the dbg call there. We don't want the dbg bang to take ownership of rect1, so we use a reference to rect1 in the next call. Here's what the output of this example looks like. Okay, similar. I don't know if we need to actually include the scale thing in here. I mean, we could. No, that's fine. Whatever. We can see the first bit of output came from the source main rs, line 10, where we're debugging the expression 30 times scale and its resultant value is 60. The debug formatting implemented for integers is to print only their value. The dbg bang called on line 14 of the source main.rs file outputs the value of rect1, which is the rectangle struct. The output uses the pretty debug formatting of the rectangle type, and the dbg bang macro can really help when you're trying to figure out what your code is doing. I suppose so. I think you could use either to try to help you understand something, but I like that the dbg bang macro is really there to communicate that you are debugging. In addition, the debug trait, Rust has provided a number of traits for us to use with a derived attribute that can be useful behavior to our custom types. Those traits and behaviors are listed in Appendix C, which we're not going to jump to now. We'll cover how to implement these traits with custom behavior, as well as how to create your own traits in Chapter 10. There are also many attributes other than derive. For more information, look at the attribute section of the Rust reference. We'll take a very, very quick kind of peek, but we're not going to read through it. So you can define a variety of different attributes here. Allow unused variables. You can target different operating systems. Allow for non-camel case types. That's interesting. So you can kind of modify some behavior there, which is pretty cool, but we'll get to that when we get to that. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work with any other type. That may not actually be true, but you can clearly see that rectangle. Like there's lots of cases where you might want to multiply two numbers, but it's not necessarily for the purposes of specifically thinking about it as a rectangle area. Although I suppose mathematically you can always impose an interpretation like that. Okay, anyway. Method on a rectangle type. Sure, I think we're basically done. Okay, so thank you for watching, and I'll catch you in the next video where we're going to talk about methods that we can put on structs just to kind of associate that area of a rectangle functionality more closely with the rectangle struct itself. and I'll catch you next time.